Next example here, iodination. So we're going to add iodine to the system. Now, when we write a specific reaction, we write reagents that can carry out this reaction. So as we look at this, eventually we will see that it is the generation of I plus that is the critical factor that becomes our electrophile. But we have to generate that, and the reagents that we can go and pull off the shelf. So this is a very important concept for you to understand. I can't pull I plus off the shelf in my lab, but I can take I2, and I know that if I mix that with copper 2 chloride, that it will generate I plus, and that can then undergo iodination to produce iodobenzene. Iodobenzene. Sorry about the squeaking of these. I don't know of a solution for that yet. We'll try and get that worked out. All right, so how does this occur? Well, I'm not going to actually ask you to do this. It's electron transfer and oxidation process, but this generates I plus, and you should know that much. You don't have to know the details of how it works, but again, how does I plus fit into the electrophilic mechanism? So the benzene ring, again, can act as a nucleophile. It attacks the electrophilic iodine. Now, this step, always the reaction of the electrophile with the benzene ring, which generates an intermediate that has lost aromaticity. This is the slow step. The slow step. So this reaction of the benzene with the electrophile is the slow step. All right, so the only thing we have left here is for some Lewis base. So copper X3 with some lone pairs, whatever happened to the rest of it there. Of course, that's going to be minus to balance the charge. Plucks off that proton. CH electrons swing down. We reform the double bond, and we have then produced our iodobenzene.